Okay, this is an experiment to test the combustion characteristics in the jet engine afterburner. I'm going to go over the project overview and then get to the experiment. Okay, so in order to increase the thrust of an aircraft gas turbine engine, an additional component called the afterburner is often used. This component allows additional fuel to be injected into the hot exhaust flowing out of the turbine, where it can combust and increase the enthalpy of the exhaust jet. This causes an increase in engine thrust. Pilots can activate and deactivate afterburners in flight as requirement for additional thrust arising during combat scenarios, maneuvers, or to overcome increasing drag while transitioning from subsonic to supersonic speeds. Afterburners are only used on fighter planes and previously on the supersonic airliner Concorde while it was in service. The problem of interest in this lab is to look for combustion instability modes in such afterburners and to find blow-off and flammability limits for various flow speeds and equivalence ratios. In this lab, we will look at some important combustion characteristics of a jet engine afterburner. Primarily, we will be interested in finding the flammability and blow-off limits for the afterburner for a given flow speed through the engine and primary combustor equivalence ratio. Group 1 will characterize the afterburner for a flow speed of 30 meters per second, which is us, and we won't worry about Group 2. Each group will vary the afterburner/augmenter equivalence ratio, measure dynamic pressure inside the augmenter for each case. Okay. Once the range of the augmenter equivalence ratios are covered, each group will note down observed flammability limit and blow-off limit. FFT and spectrograms showing how frequencies change from run to run will also be reported. Okay, so the schematic basically goes like this. Okay, so the air enters through an inlet. Basically, that's where the air comes in at a certain velocity that you adjust before the experiment. It enters a low pressure compressor, and then it goes into a high pressure compressor. Then it enters the combustor, and then it enters two turbines. The first is the high pressure turbine, and then the low pressure turbine. And then after that, you hit the afterburner part where there's a spray bar, a triangle piece that's a flame holder, and then the igniters there, and then the nozzle. And after the nozzle is the exhaust. For this particular experiment, we will be keeping the velocity of the air being entered into the system at 30 meters per second constant. We will keep the equivalence ratio of the main combustor at 0.25 constant. We will change the equivalence ratio of the afterburner from 0.8 down to 0.4 in each of runs 1 through 5. And as you can see on the right of this chart, we have calculated the amount of fuel we're going to have to enter into the afterburner to accomplish these equivalence ratios. So next you will see run 2 filmed in its entirety from the beginning to the end.
The power is running out. Oh. Okay, I think I got rid of it, right? Yeah, I think so. Both of you can run your program. Okay. So that shuts off automatically. You can close all the valves.
Okay, so that was run 2 with an equivalence ratio of 0.7. This is run 4 with an equivalence ratio of 0.5. And lastly, this is run 5 with an equivalence ratio of 0.4. I apologize for not getting runs 1 and 3 on there. I was turning the gas nozzles. Okay, so to close out, we're going to show the different components of the experiment.